Okay, now let's continue on from the first video and let's go through a homework example and kind of show you how to walk through these problems. So in this example it says, if the interest rate is 15%, what is the present value of a bond that matures in 2 years, pays 85 1 year from now, and pays 1,085 2 years from now? So let's write out our formula first. Move this a little bit here. And we know our formula for present value is equal to the future value divided by 1 plus the discount rate to the year n in which that payment takes place. I always like to figure out how many payments am I going to have and then set that up. So I'm going to say present value is equal to, and you'll notice that this particular bond has a 2-year maturity. If it's a 2-year maturity, we know we're going to have a payment in year 1. We're going to add to that the payment in year 2, but then we always add one additional payment because remember, in that final year, you're going to have not only the coupon payment, but you're going to have the face value. Always in the year of maturity, there are 2 payments that flow to the owner of that bond. Okay, so now we've got our number of payments set up. Now let's plug in some information. Well, we know that the interest rate is 15%. Right? It says right there. So we can go ahead and put in the denominator. We've got, for the first payment, it's going to be 1.15 to the 1 because it's received 1 year from now. The second year's payment is going to be 1.15 to the 2 because it's going to be received in the second year. And then the third payment is also going to be discounted by 1.15. Be careful here, it's still in the second year. Remember, in the second year we get those 2 payments. And then we plug in the actual payments. The bond pays $85 1 year from now, so we put in 85 in our numerator. That's the future value that we're going to receive. Okay. And then it pays 1,085 2 years from now. Now, in this example, it's combining the $1,000 face value and the additional coupon payment. Okay. So you'll notice that you could have just as easily have said 1,085 over 1.15 to the second. Okay. But I always like to break these up, unless it says, like in this question, it combines them together. Okay, so now we've got that, now we can do the calculations. Let's get out our calculator here. And let's see. So we've got 85 divided by 1.15. So that's going to be 73.91. We're going to add to that 1,085 divided by 1.15. Now, on your calculator, you can find this little sign or something that will get you exponents. On this one, it is the little caret sign here, okay? But you can find whatever is appropriate for your calculator. And we're going to put 2. And then we've got 820.42. And now we add the 2 together. 820.42 plus 73.91, and we get 894.33. And now we've determined the value of that bond. As a result, we can plug that in, and let's see what happens. 894.33. It says round to the nearest cent, which we did. Check answer. Excellent. Okay, so now hopefully we have a good sense of how we might answer these types of questions. But let's keep going from our previous slides and move on to a bond. Now, bonds are valued the same way. Let's move on to a stock. Stocks are valued the same way. They're using this same present value computation. The thing about stocks, though, is they're called perpetuities, meaning that unlike bonds, which have a fixed number of payments in the future, stocks, you get a payment as long as you hold it. So for a lot of people, this could be many, many years, even decades. And as a result, the formula that we just developed for bonds is going to approximate this formula here. Stocks are easier to calculate when they're held for many years. That is, the price of stocks are easier to calculate when they're held for many years, because instead of doing individual computations for every year's future values, you just plug in one formula. You don't have to add a bunch of stuff up. So let's do that. Let's say that we have a stock that yields $5 a year annually in perpetuity, and it has a 6% discount rate. Assume that dividends grow at 2% per year. Generally speaking, dividends from stocks grow by the inflation rate. Because if you think about it, firms are selling their products for more every year. Let's say inflation is 2%, then on average, firms are increasing their prices by 2%. So there'd be 2% more flowing to the owners of those firms. So usually the growth rate of dividends approximates the inflation rate. That said, we plug in the numbers. We know that this stock pays $5 a year annually in perpetuity. So that's the dividend, that's $5. We then plug in the discount rate, which is 6%, 0.06. And then we subtract the growth rate of dividends at 2% here. And that gives us 125. That means that this stock is valued in present terms at $125. Someone would be willing to pay $125 to get $5 a year in dividends, assuming these two variables are the situation. 6% interest rate in the economy, return in the economy, and 2% growth rate. Now, the same relationship between the discount rate and the value of stocks exists. As interest rates go up, say from 6% to 10% or more, the denominator is going to go up, which means the present value is going to go down. So no different for bonds. Whether interest rates go up in our formula for bonds or interest rates go up in our formula for stock, in both cases, the present value of the respective asset drops. So we can say with pretty high degree of confidence that as interest rates go up, the value of stocks and bonds go down. All right, so now let's do another practice problem. And for this one, let me pull up a question from the homework again. And for this one, it says, suppose that eLake, an online auction site, is paying a dividend of $2 per share. You expect this dividend to grow 3% per year, and the interest rate is 13%. What is the most you'd be willing to pay for a share of stock in eLake? And so we need to use the formula that we just developed, and you know now that the most basic formula that applies to all assets is present value is equal to future value divided by 1 plus the discount rate to the year that payment takes place. But when we're dealing with stocks, we can rewrite this as the stock price is equal to the dividends divided by the interest rate, discount rate, minus the growth rate of those dividends. And with that, we can plug in our numbers. Okay? So it says here it pays a dividend of $2 a share, so we've got 2. And the interest rate is 13%, so we put 0.13. And then we subtract the growth rate, which is 0.03, right? $2. 13% discount rate, 3% growth rate. And if you do that, let's get our calculator here. We're going to have 2 divided by, and we can just do this math in our head. So 13% divided by 3% is 10, and that gives us $20. So in this case, the value of the stock is 20. So let's go ahead and go here. Let's see how we did. 20, and it says round to the nearest penny, which it's a straight $20. So let's check answers, and we got it right. Very good. Here's another question. This is from the quizzes, multiple choice, and we're going to answer it in a very similar pattern as we would the homework example we just did. It says, if a stock dividend is expected to grow at a constant rate of 8% in the future, and it has just paid a dividend of $1.25 a share, and you have an alternative investment of equal risk that will earn you 12% rate of return, what would you be willing to pay per share for this stock? So the same formula that we used a minute ago is going to apply, right? Again, we've got the stock formula here, and we're going to plug in our numbers. So what's the dividend here? Well, it says $1.25 per share. And then what would be the interest rate or discount rate? Now here, the way it's phrased, it says you have an alternative investment of equal risk that will earn 12% of rate of return per year. The discount rate is the interest rate in the economy, but it could also be phrased as the rate that you could get on an alternative investment. Because if the interest rate in the economy is 12%, then that would be the alternative investment. You could take your money, and instead of buying the stock, you could buy a bond at 12%, or you could put your money in the bank at 12%. So don't be confused by the terminology or the phrasing, because the return on an alternative investment is the discount rate. So $1.25, and I would be 0.12. And then we're going to subtract the growth rate, which here it says is expected to grow at 8%. So we put 0.08. Now we do our math. And we're going to get, let's see here, we're going to take 1.25, we're going to divide that by, and again, we can do the denominator math ourselves. 12% minus 8% is 4%, so we put 0.04, and we get a value of 31.25. Okay. And in this case, we don't have to worry about rounding or anything because it's multiple choice. So we just find the correct answer, and there it is, 31.25. We'll pick up in the next video with some more applications of stock and bond valuation.